All right, Matthew, here we go. We got section lesson 8.4.2, arcs and sectors. All right, to celebrate their victory, the girls' ice hockey team goes out for pizza. The goalie eats half the pizza that has a diameter of 20 inches. So if their diameter is 20 inches, the radius is 10, so that's good to keep in mind. What is the area of the pizza that she ate? Well, the area of the pizza would be pi times r squared, so pi times 10 squared, but she didn't eat the whole pizza. She only ate half the pizza. So we would take half of that. So the area of the pizza that she ate would have been half of 100 pi or 50 pi. What is the length of the crust she ate? Well, the length of the crust would be the circumference. Circumference is 2 pi times r, and r is 10. And then she only ate half of it. So the circumference for this one would be half of 20 pi, which would be 10 pi. So this would be in inches squared, where this one would be in inches. We'll just leave it in terms of pi like that. Sonia chose a slice from another pizza that has diameter of 16 inches. So that diameter is 16, so the radius is 8. If her slice had a central angle of 45 degrees, what is the area of her slice and what is the length of the crust that she ate? All right, so there's a couple ways we can look at this. So central angle, that's the angle on the inside. So if this is 90 degrees, 90 degrees is 1/4, right? So she took half of that 90 degrees, which is 45 degrees. So it looks like she has 1/8 of the whole shape. So that's one way to do it, is to know that she has 1/8. Or we can think of the entire circle has how many degrees? It has 360 degrees. And she only wants, of that 360, 45 degrees of it. So if you reduce that fraction, 45 out of 360 degrees reduces to 1/8. It's the same thing we could have done up here. She has 180 degrees out of 360 degrees. That's what 1/2 would have represented up there. All right, so the area of the slice that she ate, we would do the area is 1/8 of pi r squared, pi times 8 squared. So this would be 1/8 of 64 pi. And an eighth of 64 is 8, so we get 8 pi inches squared. Now for her circumference, again, she only wants 1/8 of the whole pizza on the outside, and then we would do 2 times pi times r, and r is 8. So the circumference would be 1/8 of 16 pi, which comes out to be 2 pi. And that's in inches. At the end of the party, the goalie's pizza has only one slice left with a central angle of 72 degrees. Okay, the goalie's pizza was a 20-inch diameter pizza, so this means the radius is 10. So what's the area of the slice and the length of the crust? So the area, there's 72 degrees left out of a total of 360. And then we've got, not equal to, times pi times r of 10 squared. So 72 and 360, let's see, 72, let's see, 36 goes into both of those. I think what we're going to end up with, so let's see, 36 goes into this 2 times, and it goes in there 10 times. So yeah, it's going to be 1/5. So we get 1/5 times 100 pi, and 5 goes into 110 times, or goes into 120 times. We get 20 pi inches squared. For the circumference, we're going to do the same thing. We're going to do 72 out of 360. But this time we're going to use 2 pi r, and r in this case is 10. So this is going to be 1/5 of 20 pi. Well, 1/5 of 20 is 4, so we get 4 pi inches. All right, the portion of the circle, like the crust, is called an arc. So from here to here, we would call that the arc. So we can either talk about the length of the arc or the area of the arc. And the area part would be called the sector. All right, so write the formula for finding the arc length and the sector area. So the arc length would be the central angle, we'll just call that theta, over 360 times 2 pi r. So whatever angle that you have as your central angle divided by 360, because that tells you what portion this arc out here is. And then you're using the outside, so we would use circumference 2 pi r. The sector area would be theta over 360, so your central angle over 360 times pi r squared, because that's the inside the actual pizza, whereas this would be the crust. All right, find the arc length of the circle with a radius of 6, and a central angle of 30. So we're looking for the arc length. Arc length is this over here. So we've got 30 degrees out of 360. And then a radius is 6, so we're doing the length of the arc, that's the outside, so we do 2 pi times 6. So 30 out of 360 is 1/12. And then we'd multiply by 12 pi, and that comes out to pi centimeters squared. For this other one, find the sector area of a radius of 10 feet and a central angle of 20. So we do 20 out of 360 times pi r squared. So we're going to do pi times 10 squared. So 20 out of 360, that would be 1/18. That's what it reduces to. I just got rid of the zeros, and then 2 goes into both of those. And then this would be 100 pi. Now this doesn't reduce very nicely, but 2 does go into both of these. 2 goes into 150 times. And 2 goes into 18 9 times. So we can say 50 pi over 9 feet squared. This was only centimeters, not centimeters squared. Or we can just call it 50/9 of pi. So you could also write it like that. All right, next part. We're going to use the sectors of the circles D and E to answer these questions. So here's our sectors, 30 degrees, 3 and find. Find the lengths of the arcs for both of the circles. So we would do 30 over 360 and then 2 pi r. So the r is 3, so 2 pi times 3. So this would be 1/12 times 6 pi. So this is 6/12 or 1/2 of pi. For this one, we've got 30 over 60, of 360, sorry, times 2 pi times 5. So this gives us, this reduces to 1/12 again, 12. And then this is 10 pi. So reducing this one, 10 and 12 do reduce. We get 5/6 of pi. All right, so we got 1/2 of pi and 5/6 of pi. All right, for circle D, what's the ratio of the arc length to the radius? So for circle D, the ratio of the arc length to the radius, so the arc length of D was 1/2 of pi over the radius of 3. So that's the ratio. And if I were to simplify this, remember we could write this as 1/2 of pi divided by 3, which we know from 6th grade is 1/2 of pi times 1/3. Keep, change, flip, I think they taught you. So the ratio would be 1/6 of pi. For circle E, what's the ratio of the arc length to the radius? So arc length to radius, this one would be 5/6 pi compared to a radius of 5, which on this one we can do the same thing we did before. 5/6 of pi divided by 5 becomes 5/6 of pi times 1/5. So this ends up, the 5's reduce, we get the exact same ratio, 1/6 pi. So we have a constant ratio there. So there we see that the ratio is constant for a 30-degree angle. So suppose we had another circle F with a radius of 100 units and an arc of 30. What would be the ratio of the arc, it says arc length to the radius? Well, it should still be 1/6 of pi, or pi over 6. It looks like it doesn't matter how big the radius is. If I compare the arc length to the radius, I should get 1/6. And we have just discovered something we call radians. So one way to measure an angle is just like with degrees, 30 degrees. But in other levels of math, instead we measure angles using radians. A radians is the ratio of an arc length to the radius. So it's always a radian. They're usually called rad on your computers or your calculators. So it's the arc length over the radius. And here we can see that 30 degrees in radians would be pi over 6 every single time. So the radians of 30 degrees would be pi over 6. Next page. This is a long one. There you go. Next one. Choose Your Shape Pizza Parlor sells both circulars and square pizzas by the slice. The circular pizza has a diameter of 14 inches, so that's a radius of 7. And it's cut into 10 congruent slices. So if I did 360 divided by 10, that means each of those slices is 36 degrees. So those are my central angles there. The square pizza is 1 foot on a side, so it's 1 foot by 1 foot, which would be 12 inches by 12 inches. So that means that this is 6 inches and 6 inches, and then 12 divided by 4 would be 3 inches. So this is 3, 3, 3, 3. So that's a foot long right there. Let's put it into inches so that they're in the same units. So if a slice of the circular pizza costs $2, how much should a slice from the square pizza cost? All right, so let's see how much pizza we're getting for a slice of the circular pizza. So I would do 36 out of 360 times pi times r squared. So r is 7. So this is 1/10 of the pizza, which I probably already should have known that. So I've got 1/10 of the pizza times 49 pi. All right, 49 pi over 10 is what we got. Now it's this area, $2. So if I want to know inches squared, which is what I've got, per dollar, I could do it like that, or I could do dollars per inches squared. I think dollars per inches squared makes more sense. So if I take 2 and divide by 49 pi over 10? Too many videos in a row. That's my problem right now. All right, so I want to go ahead and work this out. it comes out to 20 over 49 pi, which is, let's see, 20 divided by 49 pi. All right, let me get my calculator here. All right, let's do it as a ratio here instead. So I've got $2, and this comes out to about, I think, 15.4. Let me double check that. So 49 pi divided by 10. Yeah, 15.39, so 15.4. So this is dollars over inches squared. So if I want to know a good price for this slice, I should write a proportion. I want to know the dollars, and then how many inches squared am I getting here? I'm getting 18 inches squared. So proportionally, if we're charging the same amount for the same area of pizza, this is what we should get. So we get 15.4x equals 2 times 18 is 36. Divide both sides by 15.4. So you get 36 divided by 15.4. It comes out to $2.34 is approximately what I should charge for those pizzas. Because we're getting slightly more area in this type of pizza, so it would cost more than $2. It would cost $2.34. Tanya loves pizza crust. What shape should she order? Well, so on the circle pizza, you're going to get the same crust every single time. You're going to get 1/10 of 2 pi r. And r in this case is 7. So this would be 14 pi over 10, which reduces to 7 pi over 5. So 7 pi divided by 5 comes out to 4.39. Actually rounds 4.40 inches. So 4.4 inches is what she would get of crust from this slice. But over here, I can see if she picks a corner piece right here, she gets 9 inches of crust. So a corner piece gives her 9. But if she gets one of these interior pieces, one of these 4 right here, an interior piece only gets her 3 inches of crust. So basically, she should get a corner piece like this one, and that's going to give her 9 inches of crust, and that'll be better than the 4.4 inches she gets from the circle. Is there any way to cut the pizza so that the amount of crust per slice is more equitable? So the square pizza looks like this. It's supposed to be a square. Yeah, we could cut it more equitably. We could cut it like this. And here. And if we cut it like that, we should get the same amount of crust, and there you'd get 8 slices that would all have about the same amount of crust. All right, that's all I got from you. Math hard. See you guys later. Bye-bye.